48 hours into a strict water fast, your body is under significant physiological strain. You're managing deep physical exhaustion and hunger, fueled by the conviction that your discipline is paying off. The goal is clear. You are driving your system into maximum cellular autophagy. You want your body to identify, break down, and clear out aged proteins to improve your long-term health. When your joints feel heavy and your focus begins to blur, you might be told these are signs of a healing crisis, the standard explanation in many fasting circles for physical discomfort during a detox. However, metabolic research shows that extended starvation triggers a specific shift in how your kidneys handle waste. Instead of being cleared out, uric acid begins to accumulate in your blood supply. This toxic accumulation creates a biochemical blockade. By forcing your kidneys to prioritize energy over waste removal, a prolonged fast can interfere with the very cellular recycling you are trying to stimulate. This internal conflict starts in the liver. Once your glycogen stores are depleted, your body enters a state of hyperketogenesis, flooding your bloodstream with ketones to provide an emergency fuel source for your brain. While your tissues burn these ketones for energy, any excess molecules are organic acids that must be processed and filtered out by your kidneys. This filtering occurs at specific entry points called organic anion transporters. Because ketones and uric acid share this exact exit pathway, they compete directly for clearance. For survival, kidneys prioritize ketones, pulling the orange molecules through for filtration while violently rejecting the uric acid back into your circulating blood. This evolutionary bypass ensures energy to find food, but it results in a rapid and significant spike in your systemic uric acid levels. Traditionally, medicine viewed high uric acid as a localized issue, something that only mattered if it settled in the joints to cause gout. New data reveals these fasting-induced spikes move directly from the blood into your intracellular space. Inside the cell, uric acid acts as a pro-oxidant, triggering a wave of oxidative stress that surrounds the autophagosome. This localized stress suppresses AMPK signaling and deactivates the lysosomal enzymes needed to break down waste. Consequently, the extended fasting window stops the recycling process, leaving your cells trapped in their own metabolic byproducts. To maintain your renal clearance and ensure autophagy continues to function, you can apply the Metabolic Exhaust Flush Protocol. First, cap your fasting window. By sticking to a 24-hour cycle, such as dinner to dinner, you trigger a pulse of autophagy without giving your liver enough time to create the renal transporter blockade. Second, implement a bicarbonate buffer. Consuming potassium bicarbonate or alkaline mineral water during your fast helps manage your internal pH. Elevating your urinary pH increases the solubility of uric acid. This allows your kidneys to flush the molecules out effectively, even when ketones are present. Finally, use the tart cherry defense. When you break your fast, consume non-fructose tart cherry extract or quercetin. These bioflavonoids inhibit the enzyme xanthine oxidase. This action stops the production of new uric acid the moment you transition back to eating. True biological performance depends on managing these internal exhaust pathways. By supporting your body's filtration limits, you ensure that your fasting protocol leads to actual cellular renewal.